Okay, today we shall be talking about spurious regression model and co-integration and error correction mechanism. That we shall be talking today. Spurious regression, co-integration and error correction mechanism. And it is under model 1. Okay, before talking it, we first talk about some theory. What is the theory? Regression of a non-stationary time series on another non-stationary time series may cause spurious regression or nonsense regression. A spurious model is not desirable all the time. So what is happening here? If the variables are non-stationary, and then if we estimate the regression model, probably that model is spurious or nonsense. So we cannot accept that model. Okay, here we talk about our model. In our case, we have two variables such as ex and cons, and they have unit root at a level, meaning non-stationary. So what is happening here? We have two variables such as ex and cons, but we assume that they have unit root at level, or these two variables are non-stationary. Suppose we assume that they are non-stationary, but we also assume that they become stationary after first difference. Suppose we assume that they become stationary after first difference. That is also our assumption. What is our assumption? Our assumption is our two variables ex and cons have unit root at a level, but when we convert these two variables into first difference, then they become stationary. That is our assumptions. Okay, and here ex means export and cons means consumption, right? That is the thing. Ex means export and cons is consumption. Okay. Okay, now if we run a regression model with these two non-stationary variables, the estimated regression model may be spurious or nonsense, like model 1.1 below. That means this model model 1.1 can be spurious because ex and cons both are non-stationary. Okay, what is the symptom of spurious model? The symptom of a spurious model is R square value would be greater than Durbin-Watson statistics. So that is the guideline of a spurious model. If the value of R square is more than Durbin-Watson statistics, then the model becomes spurious or nonsense. Okay, what we have done? We have estimated model 1.1. After estimating model 1.1, R square value has been 0.72, while Durbin-Watson statistics stood at 0.70. So here what is happening? R square is more than Durbin-Watson statistics. So it means that our estimated model 1.1 is a spurious model which is not acceptable. Okay. So model 1.1 is a spurious, we cannot accept it. But if the residual of the model 1.1 is found stationary, in that case model 1.1 is no longer spurious or nonsense. We can accept the model. Meaning that what I want to say here, after estimating model 1.1, if the residual of the model 1.1 is found stationary, then model 1.1 is no longer spurious. We can accept the model. So the residual must be stationary. Okay, actually here are two conditions. Number one condition, that Ex and cons, these two variables must be non-stationary at level, and they will become stationary after first difference. That is the number one condition that will have to be. And second is the residual of the model 1.1 should be stationary. And if it is happen, then model 1.1 is no longer spurious or no longer nonsense. So we can accept the model. Okay. And there is some more thing. If the residual of the model 1.1 is found stationary, it also means that variables in the model 1.1 such as Ex and cons are cointegrated, or they have long run relationship, or they have long run equilibrium relationship between them. In other words, model 1.1 is a long run model. So here what is happening? If the residual is stationary, then what will happen? The estimated model 1.1 is no longer spurious. We can accept the model. And secondly, if the residual is stationary, then the variables of the model 1.1 are cointegrated, right? Variables of model 1.1 are co-integrated, or they have long run relationship, or they have long run equilibrium relationship between them. So model 1.1 is a long run model in that case. So it is a long run model if the residual is stationary. And here so if the residual of model 1.1 is stationary, then model 1.1 is a long run model, meaning that the B2, the coefficient of cons, actually this B2 would be long run coefficient. B2 would be long run coefficient, not short run coefficient, because the whole model will be long run model. And after estimating model 1.1, B2, the coefficient of cons variable of model 1.1 is a long run coefficient, and the value of the B2 has been 5.69, and also this coefficient is significant after estimations. Okay, now we want to check whether the residual of model 1.1 is stationary or not. How to check it? And you know that how to check whether a variable is stationary. So we can use the augmented Dickey-Fuller test to check whether a variable is a stationary or not, or our residual is stationary or not. So we can check it using augmented Dickey-Fuller test. And we have already tested and found that the residual found stationary using augmented Dickey-Fuller test, meaning that EX and cons have long run relationships, or EX and cons, these two variables are co-integrated, meaning that model 1.1 is a long run model and B2 is long run coefficient. Okay, but here one thing we have done, here we need to use the Engle-Granger critical value for unit root testing. So here actually we have used the Engle-Granger critical value to check whether our residual is stationary or not. What is called stationary? Stationary means there is no unit root. And what does mean by non-stationary? Meaning that our residual has unit root. That is called non-stationary or unit root. And here actually we have used Engle-Granger 5% and 10% critical values, that is minus 3.34 and minus 3.04 respectively, to check whether our residual is stationary or not stationary, right?